Okay, there's 5 characteristics of a mineral. And what does it say at the bottom? Memorize this. Okay? Was that?
Did you make this slide?
I did make this slide. You can't stop the disrespect. I can solve that. Okay. Virginia demands that you memorize this. Well, if you're going to understand minerals, you really need to know what's going on here. And unfortunately, in education, there is just some stuff you just have to know. Okay? To understand the basis of what a mineral is and to really kind of get a grasp on this, you just have to know this. Minerals are naturally occurring. They're not man-made. Humans cannot make them. If you say, well, can humans make such and such? No. Well, we can grow diamonds, but we don't actually make diamonds. We can dissolve seawater and get salt, but we don't actually make salt. Yes? I would have to refresh on that. You take a diamond seed or a very thin wafer of a diamond, you put it in a pressure cooker, in some industrial, massive pressure cooker, and with a lot of heat and pressure with exposure to carbon, it will grow a diamond, but it doesn't grow right, it's just small little diamonds. Okay? Yeah, work on that. Not really. Diamonds are not rare. Diamonds are only expensive because De Beers holds them all in a vault. You can't have them. Naturally occurring, so they're not man-made. So that's one. To have a mineral, it has to be the foundation of our life. We can't make stuff that's the foundation of our life. That doesn't make sense. It's what holds us up. Okay? They have to be inorganic. Now, I really like to cook, and I'm really big into the organic movement as far as eating healthy. Okay? Very important to eat stuff that doesn't have a lot of preservatives, that doesn't have a lot of GMOs or all this pesticides and all this herbicides and all this other crap to it. That's eating organically. But the funny thing was, when they first started talking about eating organically, we all kind of started laughing like, what do you mean eating organically? How can you eat chicken that's inorganic? Have organic chicken. I'd like to see an inorganic chicken. Because inorganic means not alive, never has been alive. Okay, what's your question?
Oh, what? You said GMO thing?
What?
You said
GMO?
Yeah, GMO.
Genetically modified organism. So all the corn that you eat is GMO. All the soybean you eat is GMO. If you eat a candy bar, it's full of GMOs. Okay, you drink soda. Soda is flavored with GMOs. Like high fructose corn syrup comes from genetically modified corn.
So in the long run, is your life going to be destroyed?
It might. Very much so. There's a lot of data that's out there, and they're still doing a lot of testing. I think there's a lot of, I think it's just terrible stuff. Does that mean I don't like an occasional soda? I love soda, but I try not to drink it all the time. Okay. So it cannot be organic. So there's a rock. It is a definite rock. You mine it out of the ground. It's black. It gets powder everywhere. You can burn it. Coal. Coal is not a mineral. Coal is one of the few rocks that is not based on minerals because it's actually compressed dead stuff.
What?
Yeah, coal. Carbon. It's carbon from living organisms in the past, usually from the Mississippian and the Pennsylvanian and the Devonian, and then you get ancient trees and swamps that got compressed, and then you get coal. Okay? So it can't be mineral. Then it has a specific crystalline structure. You're looking at me like, what the heck did he just say? Yes, Ingrid, I interpreted that correctly. Okay. Specific crystalline structure. Okay? All minerals are crystals at the atomic level. Okay? At their very foundation, if you have a mineral called halite, you have a little bit of sodium, you have a little bit of chloride. They bond together and it makes a square crystal. Okay? You have diamond, pure carbon in the lattice work it makes a diamond-shaped crystal. Are all diamonds in a diamond shape? No. But there you go. At the very core, it has to be crystalline, and it has to have a specific chemical composition as well. So, all halite is sodium chloride. It can't be anything else, because if it was something else, it wouldn't be halite. Okay? Sodium chloride halite is also known as
Sodium chloride.
what is sodium chloride? I put it on my French fries.
Salt.
Salt. Right? It's the only edible mineral that I know of. Okay? So, but don't be licking the halite if you see it. That's kind of gross. Okay.
Wait, but isn't it just salt?
It's just salt, yeah.
So
But if you lick it and then Parker licks it, that's kind of gross. You see what I mean?
Well, I mean, why can't I just lick it and no one else licks it?
How many students have I had over the years?
Millions.
So are you saying people have licked it? Oh, yeah.
Yeah. Okay. So you have to know these 5 characteristics. They're very important. Please, please, please don't think I'm kidding when I say you have to know what these are. Because you will have to, you know how my tests are, you will have to write down, I'll say, hey, what are the 5 characteristics of mineral? And you'll say, well, they're naturally occurring inorganic solid, specific crystalline structure, and a specific chemical composition. Okay?
All in one breath.
All of it. Okay? You gotta know what these are.
Do
Okay?
you have to put the parentheses in already?
No, you don't. You just need to know naturally occurring inorganic. I'm doing that to kind of give you an idea of what's going on there.
What do you have 3 times?
Okay?
Like using
Yeah.
All right. Crystal. Let's talk about crystals. Crystals are cool. Love crystals.
Change them.
Let's change.
The crystal you see is the internal atomic structure that got to grow massively big. So this looks like a diamond growing out of quartz. This is what diamonds look like in their natural crystalline shape. Now, you guys know diamonds, it's cut by a jeweler to be very reflective. They're very, very hard. They're used for lots of things. But this is the natural shape of a diamond. It has a diamond crystalline shape. This is the natural shape of quartz. It has a hexagonal kind of prismatic shape. If I smack the quartz with a hammer,
It's me.
is it still going to look like this? No, it's specifically quartz, when you smack it with a hammer, just kind of fractures into like this like shattered glass. It doesn't look like anything but just like a broken rock. The crystal is what you see if the mineral has time to grow slow. Okay? So what you should be writing down, a crystal is what a mineral would look like if it had time to grow for a long time. Okay?
Master Joe. Yes, it is a last two.
Okay. So that's crystal. The next slide, we talk about kind of the same thing. Okay. All minerals must be crystalline because it's like number 4 of the 5 characteristics. It has a specific crystalline structure. But not all minerals are crystals. Okay, remember what I said? If you take these quartz crystals and whack it with a hammer, okay, this is what would happen to the quartz. This is what you would be left over with. It's just, it's fracture. It's fracture. So broken into little bitty pieces. Not all minerals break like this. Some minerals break differently. We're going to talk about that later. Cool terms called cleavage, fracture. That's what we're going to talk about later. But for right now, it's only a crystal if it's grown that way. Okay? These are online. I posted them, I put them up last night. So I worked this up over the weekend. You guys, a lot of you are asking me, do you have our test scores yet? The answer is no. I just have to run them through the Scantron machine and then post them up online. But my son has been very sick. And I spent, like Friday when I wasn't here, I was at in DC Children's Hospital all day. So he's sick.
You can do it for next quarter.
Okay. How do minerals form? They form 2 ways. Okay, 2 ways. But they always form by crystallization. Always. Always, 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 always. Form by crystallization. You can get crystallization in 2 ways. From magma or from water. Okay? If magma cools really, really slow, you get big crystals. If it cools really, really fast, you get small crystals. You see what's important for you to know here, how I've highlighted this for you so your eyes can see it better? Okay? Faster it cools, smaller the crystals. Magma is nothing but liquid rock. As liquid rock starts to cool, it gives chance what that magma starts to separate out. So all the quartzes go together, all the hornblende goes together, all the feldspar gets together, and everything starts forming these little mineral groups. And the longer you have for it to cool, the bigger those mineral groups become. Okay? So the bigger the crystal becomes. Faster it cools, the smaller the crystal. The inverse is also true. The slower it cools, the bigger the crystal. Does that make sense?
Yeah.
Nice yawn there. Epic yawn. Okay. Okay, so this is from cooling magma. The next one is the same slide, but it's about evaporating water. So this time it's not about cooling magma, this time it's about evaporating water. Okay? I like to cook. Love to cook.
No.
One of the things I like to cook is pasta. And if you know anything about cooking, which you all obviously do, you know that you must salt the water to have tasty pasta.
I have never done that.
I never
You don't know how to make good pasta.
Okay, now you know
Has to
that.
be dry.
Okay, now you know that if you want really good pasta, you got to salt the water a little bit. And if you just a second, if you salt that water up, when you boil the water is evaporating fast or slow?
Slow.
Low.
Boiling water.
Fast.
Fast, there we go. Water evaporates faster the hotter the water is. Okay? That water is evaporating really, really fast. If you accidentally, you set your hot pot on, turn on the heat, got your water, you got your salt, and you forget about it and you walk away. You got distracted because the mailman came, or you're trying to give out Halloween candy to kids, and you forget that you have a pot of boiling water, and all of that water evaporates, and you get up there right in time so you don't burn the pan, turn off the heat, and you look at your pan, what are you going to see?
Salt crystals.
You're going to see salt. What's the salt going to look like?
Burn.
Well, not watery.
Chunky.
It's going to look crystals, but it was fast evaporation, so what are the size of the crystals going to be? I mean, so small that it looks like just like a white film on the pan. Okay? That's what it's going to look like. Now I'm going to contrast that. I did an experiment in here in APES last year. We're trying to make water filters, and I allowed them to have sodium bicarbonate, and some of them kind of went overboard with the sodium bicarb, baking soda, and they put a lot of water through baking soda. All the baking soda dissolved, went through the filter, filled up these little water cups, and then life happened, something happened, we weren't able to get to the water until after the weekend, and they didn't cover the water, so the water evaporated slowly at the natural rate, and the building was cool, so it evaporated over 2 or 3 days. At the bottom of each cup, there were big or small crystals.
Big.
There were big crystals. I could visibly see these nice, square crystals of sodium bicarbonate at the bottom of the cup because they evaporated slowly. So the slower the evaporation or the slower the cooling, the bigger the crystals are going to be. Does that make sense? Okay, it's a pretty basic concept. Minerals are made of many different things. The most common minerals that you're ever going to find are silica minerals. The category is the silicates. I think I have that in notes later. So silicon, potassium, nitrogen, oxygen. Oxygen is very prevalent as well. Carbon, aluminum, and iron. Like aluminosilicates are very common. Like iron oxides are something, you guys know what iron oxide is, happens to cars if they're sit out in the
They rust.
water. Yeah, they rust. I'm going to give you a rock today that's red and very powdery. You might even see a little red powder on your desk. That's from an iron oxide based rock. Okay?
Wait. Oh.
Okay, here, okay, you see how this is a silica tetrahedra. You don't need to know that. You just need to know that this is that crystalline structure at the atomic level. Okay? And that determines the shape of a lot of these minerals. How does this interact with other minerals and how does it make up things? Okay?
How do you spell silica tetrahedra?
Silica tetrahedra. S-I-L-I-C-A space.
Oh, never mind, I see it.
Capital T-E-T-R-A-H-E-D-R-A. Tetrahedra. Oh, I want to remind you, you have a homework assignment.
We
I
have.
very rarely have given you homework. I mean, it's been a whole quarter before I've really formally given you homework.
Sure.
I want you to go to the online textbook and read chapter 2.2 and 2.3, okay, and expect some kind of a minor pop quiz. I put that announcement up on School Fusion. I put it up in the homework section. If you can't get to the online textbook, you need to let me know so you can get that done. And I'll fix it for you. It's got it's like 6 pages of reading. It's not very long, but it explains this stuff really well.
That's crazy
Say it.
right there.
It's pearsonsuccessnet.com. It's online. You can look it up on School Fusion. Lopez?
Do I need a passcode or username for that?
Yeah.
It's like, I don't know, I don't have one then.
All right. We'll talk about it.
Alright.
Okay.
Do I need to do that? It's
Okay.
This is the first time in school.
I just want to kind of like plow through these. A mineral's properties are determined by the internal arrangement of its atoms.
Can I write that down?
If you want to.
Alright.
And that could be on anything.
Okay. This is pretty simple. Now this looks like, oh, this is so complex. Okay, on the left I have a picture of
Pencil?
pencils, and specifically I'm going for that
Lead.
black stuff. What's that?
Lead.
It's not lead, it's
Minerals.
graphite.
Graphite.
It's graphite. So
Holy.
graphite
That's lead.
is what your pencils are made of. It's a very soft carbon mineral. It's 100% carbon.
Whoa.
Well, over here I have a very hard carbon mineral that's in a crystal structure.
Is that diamond?
That's a diamond.
I got it.
Okay? Both of these are made of carbon, but one of them has the internal arrangement of a crystal lattice work, and the other one does not. They're both minerals, they're both carbon, but they're arranged differently. And that makes a different mineral.
So they're both not.
So the same mineral, but a different mineral.
Same element,
Different form.
different mineral.
Oh.
Okay, say it.
I think like the diamond, the light clear,
Not all diamonds are clear. Not all quartz is clear. All depends on what is imperfection in the diamond. Okay? So minerals' properties are determined by the internal arrangement of its atoms. Well, the diamond, its internal arrangement is a crystalline structure. The structure, the crystalline structure of the graphite is more, I believe it's in sheets, or it's a very different lattice work on the inside. Thus, this is very soft. This is very hard. Okay?
Same as you notice.
Did you get that happy?
What'd you
put on
my hand? I just take a picture.
He tickled your hair.
Okay, ore.
So sweet.
Ores are where metal can be extracted for a profit. Okay, metal extracted for a profit. This is pretty simple. If I'm digging in the ground and I find gold stuck to some other rocks and minerals, that's an ore. Because if I mine the gold, I can sell the gold. I can go down to Gold and Silver Pawn Shop. Friar Rick Harrison, I have gold to sell. He will say, here's your money, and I walk out the door.
Happy.
Right? Because gold
It's
has
worth money.
inherent value because people value gold.
Why?
That's a good question.
It's a rare element.
It's usually because it's more rare, it has a lot of properties that can be used,
it's
and a lot
shiny.
of things. It's shiny.
How strong is
Gold is
titanium?
silver.
Okay? So silver is also one of those
Pretty strong.
more valuable minerals because people want it. And so we can extract it and make money by selling it. Say it?
Are good. It's like gold rare or like diamonds.
Gold is much more rare. Well, I'm not going to answer that question because I don't know. Diamonds are not rare. Gold is not rare. But it's hard to get.
Even light.
wish we made like a big instead of
Oh,
all
want
the
some
way
chocolate?
on the feel like just 2 ounces of chunks and just.
That might be true,
Thank you.
that might be true, but that's a
You want
lot of gold.
Wait, what did you say?
He said something about how big gold could be. You have to understand, like diamonds are not rare, there's lots and lots of diamonds. Diamonds are expensive, gentlemen.
Sorry, sir.
If you're gonna talk in front of the camera, it's gonna show up on the video.
Oh.
Diamonds are expensive because there is a company called the De Beers Company that owns most of the diamond mines, that owns most of the diamonds that come out of the diamond mines, and they hoard them. So because they have most of the diamonds that are ever made in a safe vault somewhere, they make the supply of diamonds smaller, so the demand for diamonds increases, and then the cost of diamonds goes up.
That's stupid.
It's called a monopoly. Whether it's stupid or not, it's reality. So girls, if you want a diamond, I'm sorry, it's the beers that make it expensive. Okay? Okay, so pyrite is a common mineral ore. Now, throughout this presentation and throughout like the next couple days, you want to be thinking to yourself, what are the uses of the minerals Mr. Korrick is talking about? So, graphite. What's a use for graphite?
Pencil.
Writing.
Pencil lead. What's a use for diamonds?
Jewelry.
Rings.
Jewelry. Okay? Diamonds can also be used as industrial grade abrasives. Okay? So, if you want to have a diamond tipped drill bit, you can cut into really hard things because diamonds are so hard. Pyrite is used, it's a mineral ore. They would take the pyrite and extract the sulfur to make gunpowder. Prince William Forest Park, there was a pyrite mine until the 50s, and 40s, 50s.
What happened?
And they were extracting the pyrite to make gunpowder. Now they have better ways to make gunpowder, so they weren't making any money, so they stopped extracting the pyrite.
So is there a lot of pyrite?
Was that?
Is there a lot of pyrite?
Pyrite's fairly common.
How would
Yeah.
this one come from?
I have no idea. Let's go on. Okay. Oh, thank goodness, now we're to the fun part of class. Okay. With this is kind of I gave you a background of what minerals are. Now let's talk about how do you know the difference between this mineral and this mineral? How do you tell them apart? Okay? Okay, different minerals. So what we're going to be doing is using different tests to determine what the minerals are. There will be a lab practical. Lab practical means for your minerals test, there's going to be a portion where I ask you to come up to me, or I'll give you a separate sheet of paper, somehow I'm going to do it, and you have to distinguish between 2 or 3 different minerals and tell me what they could or could not be based off these tests. Okay? Well, the first test. Now, all of these are going to be in the notes, so you don't have to worry about copying all these down, because we're going to talk about each one individually. Okay? And if you look in the book, you'll find them there too. Say it.
So you said that the salt
Trying to make my
mineral
camera
that you know
it's
that
really
you can eat. I mean, like you could eat pencil lead, but it's not gonna kill you.
Can you go back? I've had that one. I like how
It's not gonna kill
like
you.
my
Say it.
I know you don't eat it, but you can, and you're not.
Alright, can I go back?
I've seen somebody do that.
It'll all be like, see the heading here, color?
There's a difference between something being edible and you just eating it.
That's good to know.
Okay,
Like salt is edible. You're just eating pencil lead.
okay, color. What is the basic color of a mineral?
Like I can eat.
Right.
Can.
Like,
Can you do purple?
Minerals have different colors, and color is actually kind of a low quality test. Why is it low quality? Well, here's why. This is 5 different colors that quartz can be. Quartz can be almost any color out there. Quartz is so many colors. Why? Because it's all about the imperfections and the other stuff that's in the quartz cause it to be different colors. Has anyone ever heard of amethyst?
yeah.
Quartz. Okay? Amethyst is just quartz. Rose quartz, amethyst, purple quartz is, I think, amethyst, you know, all these different colors of quartz. Even have gray quartz. So, color's not the best determining factor. Oh, it's blue! It must be such and such. Well, that doesn't really work because a lot of things can be blue, and they don't always have to be blue. And we want tests that are a little bit more concrete. So yeah, color's helpful, but not always helpful. Does that make sense? Okay? So that's just color. Okay? But streak! Oh, streak is an important test.
Oh, come on, man. I was copying it down.
Okay. Streak is an important test. Here I have, these are streak plates. Okay? They're made, I believe they're made of ceramic. They're very hard, but that doesn't mean they're really, really strong. So if you chuck it on the floor, it will break, and I will be displeased. So, I'm going to hand these around while you're taking notes. Okay, streak plates. Okay, so keep writing down what you need to write down. Give me it. That's what I need.
Oh, wait. How do you, like, clean them? Do you, like, stick them in a dishwasher or something?
That should work, actually. It's just a powdered mineral on top. Okay,
It's like,
streak.
That's okay, I see. Cause like, don't.
I'm going to be handing out,
Blend together.
I'm going to be handing out some different minerals.
You're on the back now.
Okay, this is a black streak plate because some minerals have a light colored streak that's harder to see. So what you do is you take your streak plate, you never do this in your hand because if it breaks, or because sometimes you have to push really hard to get this to work. If that happens, you can hurt yourself. So always place your streak plate on a solid surface, okay? Take your mineral sample. If I want to know what is this mineral sample, one of the key determining factors is what is its streak. All minerals have a different colored powder. The powdered mineral is what I'm looking for, and I'm going to powder it by rubbing it against something hard.
So even the, different colored quartz have the same streak?
It always has the same streak. So I rub this mineral, and this is probably hard to see, but this mineral has a white streak.
You're done?
Okay? So I'm going to hand out to you
You're welcome, Joe.
some minerals, and I want you to figure out what color the streak is. Okay.
You're welcome, sure.
Shouldn't we wipe off the previous streak?
Always a problem. If you can't find an empty spot, try to wipe it off. I've got some paper towels. Okay.
Ardbet.
No, please don't.
Ardbet.
Yes, that would work, but graphite gets everywhere. I have samples of graphite, but I don't ever give them out because they just get everywhere.
what's graphite used for?
Graphite is the mineral that your pencil lead is made from.
What is this doing?
Try and run on your paper.
Can I get a piece of paper towel, Mr. Ford?
No, I'm trying to
Don't try to line up. Maybe grab your nose.
Can you guys,
How can you chocolate down all the chocolate I Definitely. Dude, this stuff.
Do you want some candy?
Oh.
Can I have more candy?
Can I pour water on it?
Yeah, exactly.
This is really sharp. How much jokes that will make felt it? Have you felt this? I feel this. Yeah, you can. See that? Hey, did you chew these? On Friday?
This Friday? Last night, no, but just one straight. It's gonna be at the school at 3:20 in the morning.
3:20 in the morning, man. It's all
guys, just one streak. Don't be painting it on there.
Just one streak.
Oh, because it was in
Get one good streak.
Oh, yeah?
That's how I have it.
You guys go in the
Okay.
water?
What is the color of that mineral?
Black.
What's the streak color?
Black. There's no colors.
Yeah, it's like a dark gray, almost a black. The mineral I gave you is
Pyrite.
pyrite.
I have a question. When is the next hurricane?
What was that?
When is the next hurricane? When is like the next hurricane?
Stay on topic. Okay. Okay. Yeah. Okay. Listen up. Stop. You don't want to be painting this on there. I've got to use these for other classes. Okay. Streak. Now, this is an important, helpful tool. Why? Well, pyrite is also known as fool's gold.
Yeah.
And you guys, all being educated mineralogists, will know that, oh wait, this cannot be real gold because its streak looks like this. It's like a dark gray. But if I actually had some gold, which I don't, so don't ask, I do not have any gold, and I was to use a gold on a streak plate, it would come across yellow, yellow gold, because gold has a gold streak. But pyrite is a gold color, but has a dark gray streak. So you can say, oh, this is pyrite and this is gold because the streak is different. Does that make sense? Cinnabar is just a different mineral. Yeah.
Look at these.
Well, if you run it hard enough and long enough, you're just going to run out of mineral because you're powering it all. Crickets? I'm not quite sure what you're saying. Okay. Do you guys have any questions about streak on this test? Is this a pretty simple test? Yeah, it's a pretty simple test. Could you duplicate this test, Michaela?
No.
Michaela, if I gave this to you on a test and I gave you a streak plate, would you be able to do it?
No. Maybe. Yes.
I hope you will. Okay, next test.
Do you have any candy bars?
Okay, next test.
I do have a chisel.
This is the Mohs hardness scale. This is the hardness test. Now, the hardness test. The hardness test is all about how hard is the mineral. Some minerals are really soft. Some minerals are really hard. I have here a rock. I'm going to be passing out samples. I want everyone to really get a chance to touch this stuff because this has got a really fun texture to it. So,
It feels like glue,
3
don't it?
tables. Passing
Did you do your story last time?
Okay. Your 3 tables.
You know what's due today, right?
The project, like the story card.
So am I.
Okay. And we have 2 seconds.
I pissed it off. I just realized. What?
Okay.
I just saw it.
Get a feel for the sample. Rub your fingers on it.
It's nothing.
Don't worry, it's not toxic. At least not this one.
You gotta have plenty. I can't. Is that the chocolate bar?
I'm not going to tell you which one it is.
Oh, it's not. Is it rock?
You wouldn't.
I thought it was like.
It looks exactly like a rock.
Every day was
What
about this? Like,
Okay.
like this special.
Okay. What do you notice about this sample that I handed out?
Powder.
And didn't want
It's powdery, dusty.
And salt.
Okay. What I want you to do, hold up your sample. Okay.
John,
I want you to hold your sample as a group now.
John.
When we're doing the hardness test, what is a mineral's resistance to scratching? A diamond will scratch everything. Talc will scratch nothing. Hard, soft. Now I'm in the middle. Okay?
Scratch, what do you mean by scratch?
Now, I'm going to take my fingernails and see if I can scratch this rock.
And you did it.
And I can easily scratch this rock, no damage to my fingernail. So that means that this particular mineral is not as hard as my fingernail. So that means it has to be either gypsum or talc. This particular rock is very powdery, and if you make it into a fine powder, you often put it on babies' butts. What is this called? Talc or talcum powder. Right?
What?
You've been touching this stuff. It's not a
Okay.
Someone just come.
This is talc. This is the softest mineral. Pay attention, guys. Okay. Now I have a testing kit. While I'm getting the testing kit out, I want you guys to see if you do the fingernail test. Okay, test this rock. See if you can get your fingernail to be harder than this rock.
Not a rock.
This rock. Okay.
Will it take off when you scratch that?
So what happens? Yeah.
Yep.
It's not trying.
I'll go ahead.
Okay. I got it. I want to go home and watch
I was planning on going to see this one was up to here.
This part you have to make your own. I know. And I didn't do that. I didn't do that either. I didn't know we did. I think that's the only thing I didn't do. Let me see that.
Okay. I gave you guys what's hardness testing kit. In there, you have a copper coin. You have a piece of glass. Did you guys not get one? You guys not testing that?
Okay, let me see that.
You guys do one?
What's inside here?
Okay.
You can't hear.
This is a hardness test kit. Now, your fingernail is about 2.5. Okay? Now your fingernail is not organic. I mean, it's organic, it's your fingernail, but it is still about 2.5. Copper coins. Now, pennies are actually worth something, or the copper in pennies is actually worth something now. So they don't make pennies out of copper anymore. If you get the old pennies, this works. Pennies are about a 3. Somewhere about a 3. This says they're greater than 3. I've also seen they're about 3, so somewhere in there. If you take a stainless steel blade, like a Swiss Army knife, Swiss Army knife is usually about 5.5. But if you have straight steel, it's a little bit harder. And glass is anywhere between here to 7. Why? Because it's all what the glass is made of. So this particular glass actually I think is a little bit harder than this. I think the glass is at about a 6. Okay. If I was going to do a test, and I wanted to know how hard or how soft something was.
What's that?
Wrestling. I used to be DMX. And then they broke up. It was like Triple H and like Shawn Michaels. Yes. Suck it. Suck it. No, thanks. I got the Generation X. When I stopped watching it every day, I got tired of it. I stopped watching it. Watch it on TV. Nah, I don't watch it. I watch that. I watch that keeping up to it.
Okay. So if you wanted to determine what is this mineral,
It's topaz. Head up. Yo.
Hey, you watch Kabuki.
You know others?
You said you watch Kabuki. Call me back.
What's your name?
Oh my god. You're probably gonna do this over again.
Okay.
I have like no key.
Just feel like a puppet.
Are you guys done talking?
Yes.
Stop. Okay. If you want to do the hardness test, this is actually a very simple test. At least in theory, it's a simple test. This is your Mohs scale of hardness. All minerals have a different hardness. To do the hardness test, okay, this mineral, I don't know what it is. I have no clue what this is. How do I know? There's some tests I could do. I could find its streak, right? That's one of the things we talked about. We're on test 2, hardness. Well, let me see. Is it harder or softer than my fingernail?
It's not this harder.
Yeah, it's harder than my fingernail. It's kind of like filing my fingernails. So it's harder than my fingernail. So it's harder than 2.5. Does that make sense? It's harder than 2.5. I'm going to try the nail, see if I can scratch it. Well, I always want to be safe. Put it on the desk. Whoa! I can scratch this mineral with the nail, so that means it is not quartz. Because quartz, even though it could look like quartz, quartz will not be scratched by a steel nail. Just won't happen. So I know that it's less than 6, but more than 2.5. Okay, and you can start narrowing it down. So I should be able to find where's your coin.
I don't watch TV.
Coin? Can I scratch the coin?
Yes.
Yep. The coin scratches it as well. So, wait, no it didn't.
Until you read that.
Oh, never mind. Yeah, I got that backwards. This actually rubbed the finish off the coin. So this is harder than the coin. So it's harder luster. Okay, luster. Luster refers to how shiny something is. Or actually more specifically, what kind of shiny something is. Now, this is defined as either metallic or non-metallic. Okay? The luster test is it shiny metal? Or is it not shiny metal? Okay?
It doesn't.
I've got some samples for you.
Welcome to.
I'm sorry.
I know what it is.
Okay? Okay, no, I'm going to go back. Minerals have cleavage and they can have fracture. But all minerals have either or. Okay? And you can have many planes of cleavage or just one plane of cleavage. Now, what the heck is cleavage? Okay, this is what makes us all giggle because we've all seen the girls that are inappropriately dressed in the school. Okay?
I don't.
Now-
Never.
We all know.
Or maybe it's some really big, heavy dude inappropriately dressed too.
How do I dress in a pro? What? Nipple pop.
It's pretty hot in here.
Okay,
Sorry.
ladies and gentlemen. When a rock has cleavage, it breaks along certain planes. Okay? How many planes does a cube have?
4.
8.
8.
6.
Planes.
6.
Not sides, planes.
Oh, you just need it.
3. A cube has 3 planes. Right? We have, right? That's the face of the cube. Like up and down is one plane. Okay, and then back and forth along the top is one plane, and then you have a plane going left and right. Okay? 3 different planes. How much cleavage does a cube have? How many planes? It has 3 planes. How much cleavage does it have? 3. Okay, this is a mineral. Now, This mineral, these are really, really pretty samples, so please don't scratch these up. I want to keep using them because they're so clear.
I'm not gonna.
There's no other test on it.
These are minerals.
Are those natural?
Dude, not even right on.
Not just
These are natural. This is their natural shape. 1, 2, 3.
That's stronger than I guess.
Okay. 1, 2, 3.
Wait, where are you?
And 1, 2.
How is it?
Mine's bad.
That's good.
I don't even have mine.
You're lying.
No, I did. My mom's car. I think we melted.
I didn't take one though.
Really?
I have medicine for my wall though. I made my own wallet.
Is this laminated? You said yes?
No, sir.
What is this?
Is this its natural state?
Yes.
Don't break it.
I know, it feels like it's laminated.
Pretty.
Okay, you like my wallet?
Like the oldest one. No.
Oh my god, that is scratched. Like this is
Okay.
They're all the way here.
Cleavage. Let's talk about cleavage. Minerals have cleavage when they break on different planes.
Oh my gosh.
Okay. The first sample I handed out to you is called calcite. Guys? The first sample I handed out is called calcite. The calcite has 3 planes of cleavage. Do you guys see that? It's 3 different planes. Now, they're not necessarily straight up and down. They all have different angles, but it's still 3 planes. Now,
Why does she look like that?
Hey, you should order one.
No.
that's not me against you, the donuts. It's the middle. Okay.
My sister gave me her ring right now.
Guys, I need you to listen up, please. Guys, I need you to listen up, please.
Hey guys.
Okay. The calcite has three distinct planes of cleavage. If I hit that calcite with a hammer, please don't. If you hit it with a hammer, it will break, and every piece will look like it is right now. Because it always breaks on those planes. Those are the weak parts of its crystalline structure where it's always going to break at those points. Okay? Now, look at the other sample, that little flake that I gave you. Hold on. Look at the flake piece I gave you.
What is it?
Okay, that is a piece of mica. Okay, hold your question, Syed. I'll give you a second. Okay, this is mica. This is actually a really big piece of mica. Okay, you know here in the light here. Mica is non-metallic. It's kind of like more like a glassy. You can reflect it. It's glassy.
It breaks easily.
It's non-metallic. This particular stuff, you can see how it's in tons of different layers. It's very weak on one plane. It's very strong the other planes, but it's very weak on one plane, so it flakes into sheets.
So I thought that was cable, but I was supposed to.
This is mica. Mica is often used in insulation and wires and things. Oh, that's important. I'd write that down.
Mica
Mica is used
M-I-C-A.
is used.
Yeah, insulation. Insulation.
And
Like wire insulation. Copper is a different it's an element mineral.
I hate my country. I have some Bangladesh friends.
Which is, means it's a compound of different things. Do I know what those are? No, I don't cook meth. Okay.
Not my YouTube Spanish. No, I can't.
You can have different types of cleavage. This is one plane of cleavage, 2 planes of cleavage, 3 planes of cleavage. That's what you have, 3 and a 1. And 4 planes of cleavage. This would be like the actually, I'm not sure of one thing off the top of my head that is not shape. This is different than crystals. Listen, this is important. This is not the same thing as being a crystal. Why are you talking? Crystals are crystals because they grow into that shape. If you break them, they will not necessarily maintain their shape. Cleavage is when you break it and it always forms the same shape. If you have table salt, okay, table salt, if you look at the small pieces, what are the shapes of those pieces? They're squares. They're tiny little cubes because halite has 3 planes of cleavage. It's cubic. So if you start breaking down little pieces of table salt, unless you powder it and get it under a microscope, you can see that it makes more cubes. No matter what you do, it makes more cubes.
Where can you buy this?
Where can you buy what? You can find online stores and so on. Natural History Museum? Yeah, they have a lot of natural history. Okay, let's talk about fracture. Okay, if it doesn't have cleavage, it has fracture. Okay, I think I have some samples of this. I have samples of lots of things today. Alright, take a look at that and then pass it down. Guys, take a look at this and then pass it down. Alright, take a look at this and pass it down. Alright.
Oh, we're supposed to pass it. Are we supposed to pass it down? Are we?
Okay. Quartz. Okay, quartz has fracture. Quartz does not have any planes of cleavage whatsoever. So when you break quartz, it doesn't make nice, clean breaks. Right? It doesn't have the flakes. It doesn't have the 3 sides of the rhombus or the prisms or the whatever. It doesn't. It has fracture, and when you break it, it shatters like glass. And it often has these ripple effects on it. And if you miss this, and you lose the question of the test, I will hurt for you. And I don't want to hurt for you. Come on, man. All right. So this is called conchoidal fracture. Okay. Kyle, put your phone away. I don't want to see it again. Okay. Quartz. Well, what do we use quartz for? Well, quartz is often used in making glass. You melt down quartz and you can make glass from quartz. Sandy beaches, really, really far away from mountains like Myrtle Beach, Ocean City, the typical kind of yellow sand. It's made of quartz. You can melt it down and make glass. So it also uses in crystals and watches and electronics and other things. Sand. How would you melt sand? In a very hot furnace. Okay? But quartz has no cleavage, it has fracture. So if it's not cleavage, it's fracture. Okay.
What are you doing? He's being artistic.
Alright.
Actually, yeah, no, artistic.
No.
John? What does it say?
Okay.
What's it say? You dissing me? What does it say?
serve this message. Oh, those are scratches.
Let's get into the fun stuff.
What a drama.
Even though I just got my name.
Hey, that's class. You said that you're a college student.
So they find this stuff. Tell me all the time. I said, you told me already.
Oh, press out. I think was okay, copy all that down.
Okay. You guys remember that really silvery, shiny mineral?
Mercury?
Okay, you should still have it at your station. Okay? Pick that up and compare it to anything else. Go ahead and pick up the galena. No. Pick up the galena. Don't drop it. What do you notice about the galena as compared to everything else?
Really, really shiny.
It has like different.
It's surprisingly heavy.
Yeah.
Surprisingly heavy. Okay, galena has high density. Each atom of galena is very, very heavy atomically. Okay? Galena is made of some cool stuff. Lead and sulfur. It's a lead sulfide, as opposed to pyrite, which is an iron sulfide. Okay? Galena, being made mostly out of lead, makes it very dense. There's a lot of mass in a small amount of volume. It's very dense. Okay? Galena, magnetite, gold, these are all very dense minerals. Quiet, please. Guys, I'll give you time to look at minerals, but there's other times you need to talk. We need to pay attention. There you go, you're already messing with my brain. Alright, stop. Okay? We have already done this test. We did it earlier in the year when we did the density lab. Okay? That test is called specific gravity. Yeah. Okay, the specific gravity test, I might ask you, how do you do the specific gravity test? Your answer is, you compare the density of the material with the density of water.
What?
Okay, compare the density of the material with the density of water. Or, you put an equal amount of gold and pyrite into water and measure the densities. The more dense something is, the more water it will displace.
So the denser something is, doesn't it float in water?
I have a video.
Switch it.
I tried it.
The more denser something is, the more it'll sink in water.
Wait, but so water is denser than ice.
You ever
Yes.
do that? It's like
So ice floats because water expands as it freezes. It's actually one of the very few things that does. Water expands as it freezes because it's taking up less space with the same amount of mass. It becomes less dense and it floats. It's one of the reasons we can have life on the planet, because if water was contracted when it froze, then the water would freeze from the bottom up. Or water would freeze at the top and then sink to the bottom. Okay? And then all the frozen stuff would accumulate on the bottom. It would never melt. And then the oceans would freeze over and we'd all die.
picture over, not with it.
That would be very bad. But water floats, so that's a good thing.
Oh, yeah.
Okay? Do I have any gold? I don't drink as well.
You took it and it's like
Okay. Alright, do you guys still have the calcite?
Can I trust you with my phone?
The calcite is the clear one? Or the clearish one?
I have a, you can look at
Are you gonna get any more tattoos? Yeah. Which one should I list last one?
Yeah, you can't read
it. It
that.
doesn't matter.
They're all plus.
I think.
Nah, I can't read that.
Yeah, I can't do
Oh, the last
it.
one, no.
If you look at
It's hip-hop.
the calcite and try to read through it like a glass, do you see how it kind of changes the light? It gives you double vision. Double vision. Right?
Can't see you.
Okay? If you can, look through your calcite.
Well, that's your phone.
Dude, this is so funny when I look through it.
Oh, he's yeah.
Yeah, that was all. Check out that. Put on paper. Okay, there's a lot of special properties. Lots and lots of special properties. One of them is double vision, or actually double refraction. Okay, have you guys been able to look through it?
Hey, that one too. Hey, yeah, that's really bad.
It's the last one.
How come this one's like cloudy?
It's all about what's inside the mineral and how pure the sample is. Yes, but not all samples are pure. Okay, did you guys were able to see through it?
Yeah.
Oh, this one? No. Oh, yeah, it makes the whole vision.
Yeah, it makes it
I saw it. Is this what you make glasses out of? No.
Okay,
Eyeglasses?
did you guys get to see this?
Yeah.
What eyeglasses?
Salt.
He
No, it's not
tasted
salt.
it. Yeah, he did. I promise you. He was like, "Oh, let me take pictures." Oh, don't watch
What is she doing?
I was thinking. I deleted it. I don't like when I put videos up and like that. No, yeah. It's really easy. Yeah. Like trying to focus your eyes. What are you going to? What's he doing? You can't look at my pictures. No,
You have to.
Wait, what? Wait, give it back.
So this is one of the special properties about calcite. Calcite shows double refraction. And by the way, calcite is one of the main elements, or not elements, compounds, sorry, compounds, minerals in limestones. We mine limestone and we use limestone to make concrete. Uses of minerals. If I said calcite, what would you say?
Concrete.
Concrete. Concrete. Okay? There's that one. There's the fizz test. I'm going to skip the fizz test today because my acid's not strong enough.
Oh, I got some.
I'm struggling with it.
Yo, you want to give me
I'm going to try to because it's an awesome test. Alright, pay attention here. This is important. It's a layup. If you drop acid onto a rock and it starts to bubble and fizz and react,
Probably true.
the rock has to have calcium in it, specifically calcite.
What happens if you drop the acid in milk?
And nothing happens? That means it doesn't have calcite in it. It's the acid test. Carbonates react with dilute HCl and other acids by fizzing or bubbling. Okay? The acid test tells you whether or not it's a silicate rock or carbonate rock? If it's a carbonate rock, it will react. If it's a silicate rock, it will not react. We use this in the field to determine what kind of rocks are what, because sometimes it's hard to tell the difference between a silicate and a carbonate, because they're both white in color at times, and they both, when they're in another rock, it's hard to tell. So if you have a little bit of acid, you can drop a drop or two of acid on the top, and it will fizz up. If it fizzes up, it has to have some kind of calcite inside. Does that know?
What's that type of acid that like melts up?
Well, HCl melts a lot of things, or I should say, melts is not a good term. Corrodes. It eats away at.
J.
Melanie?
It's an J-A-Y.